A 4-stroke model internal combustion engine part 3. My friend Andrew arrives at my workshop after making some modifications to his engine. In this video we try a test run using my newly assembled engine starting system, and I show him an old Laser 80 4-stroke engine. In the meantime, Andrew has been very busy. He's made a new piston ring for the engine and he's also made a new rotary valve. And now as I rotate the propeller, there is a big difference. It actually has a compression stroke. Time to get out my newly assembled starting kit. Here it is, the second incarnation of this kit, as the first battery seemed to go a bit wrong. In the foreground is the electric starter, and here I'm using the starter to rotate the crankshaft on the engine. That sounds and feels a whole lot better. I'll spin it a bit more to bed things in. It really does sound so much better. Time to add some fuel. This stuff is 25% nitromethane, so I'm sure if it's going to run, it will run on this. The carburetor isn't fitted and I haven't flooded the engine. This glow clip refuses to stay on the engine, so here Andrew is holding it from behind. Are we ready?
Yeah.
Fingers clear.
Yeah.
Well, the engine did actually pop a couple of times before the brass prop nut came off. The thread on the crankshaft is still very small and very finely threaded. I assumed it to be M6, but it's not. I have a drawer full of various metric nuts and bolts, and we tried a few of these and none of them fitted this thread. I looked in my box of metric bits and found a die. The die said M6 1.0, and when I tried this on the shaft, it sort of fitted. I'll give you a clue, it's one that's slightly bigger than this one. After hunting around for different nut sizes, here's a clip from when I first saw this engine and had it on my workbench. This was the original arrangement and it was no good at all. Internal combustion engines, no matter how nice they look, are very brutal things. Every firing stroke is like a bomb going off inside the cylinder, perfect for destroying any parts of the engine that aren't strong enough to cope with the stresses. This small lock nut arrangement was no good at all. You would think that as the propeller rotates in a counterclockwise direction, it would be better to have a left-hand thread, but this is never the case. I'm going to show you the difference between a commercially made 4-stroke engine of the same capacity, 10cc. This is an OS FS60. It is obvious that at the propeller end of things, this is a very strong construction. With this arrangement, you can really tighten the propeller onto the knurled part of the front of the prop driver. It is worth thinking about the fact that 4-stroke engines often backfire and throw the prop. I think that the front of the crankshaft, the bit that's threaded, is far too feeble on this engine for the job it's supposed to do. A popular size is 5/16 UNF. If you want to play with metric, then possibly 8mm will be okay. But you need quite a lot of thread to engage the nut on. After this first test with the electric starter failed, Andrew dismantled the engine to see what the problem was. Then he put it back together. This was all to no avail because the prop nut flew off again. I was speaking to Andrew about this and he decided that he was going to take it home and radically modify the crankshaft. He did say he was going to use an 8mm thread, so we'll see how that works out on the next test next week. As the test was a failure, I thought I would show Andrew my old Laser 80. I bought this via eBay a few years ago. This one is 13.5cc approximately. Here's Andrew's engine when I first had a look at it in my workshop, and here's an extract from that video. As far as model engines go, this is not something I would like to tackle as a first attempt, which is what Andrew did. This is someone's first attempt at making a 4-stroke engine. Not just any four-stroke engine, an engine with a really complicated rotary valve system. By comparison, here is a really old OS FS60 10cc four-stroke engine. This was after I changed the bearings because they were worn out. The difference in the sound of the engine was quite amazing. To conclude this episode, this is how the engine sounded before I changed the main bearings. I'm really hoping that once he modifies the crankshaft, it will run okay. That is it for this episode. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.